Okay, this is the correction and dumping for the motion test that we just took. Remember, in order to receive credit, you are going to have to copy and write everything that we write and make sure that you get all the correct answers. Number one, which of the following statements best describes how the speed and velocity of an object differ? Well, we know speed is simply distance divided by time, and we know that velocity is the speed or distance divided by time with direction. That is the only difference between speed and velocity. So speed is distance over time, velocity is direction and speed. So letter A, velocity specifies speed and direction. Yes, it does, while speed has no specific direction. That looks like a good answer, but we're going to go ahead and check the rest of them. B, the velocity specifies speed while speed includes direction. No, it does not. Speed does not include direction, only velocity does. Velocity specifies change. Uh-oh, that word right there should obviously make you think of acceleration, not speed or velocity. So that cannot be our answer. Velocity is not changing, only acceleration is. And D, velocity specifies a change. Uh-oh, we got that word change again. That's acceleration, not velocity. Number two, compressing a spring. Compressing. When I compress something, that means I'm basically squishing it. When I squish something down, I'm going to be pressing down on it, and a spring is kind of a coil, and we press down on it, it's going to become a tighter coil. Compressing a spring increases its what? Kinetic energy? Well, obviously it's going to be moving, but we're not really increasing kinetic energy. What are we doing? We are increasing its potential. We're increasing its ability to boing and to bounce up. The more that we squish it down, the more it's going to bounce up. So it's not increasing kinetic. Electrical, that has nothing to do with electrical. It's not plugged into any sort of wire. Or chemical, there's no chemicals involved. So really it's between kinetic and potential, and the best answer there is potential energy, because as you squish that spring downward, it's going to have more stored up energy to jump up faster and higher once you finally release it. Number three, a student rides the Ferris wheel when visiting the amusement park. During the ride, she moves at a constant speed of 3 meters per second. Well, we hopefully have all been to a Ferris wheel, and a Ferris wheel goes round and round. So it is turning constantly or changing direction. It does say here that it is going at a constant speed, but not a constant direction. If it's turning or changing direction, then it is changing its velocity. Which of the following best describes the motion of the student on the Ferris wheel? The velocity is changing, yes, because the direction is changing. Yes, the direction is changing because you are constantly changing from going up to down, sideways to frontways, and all around in a circle. The velocity is not changing. Well, that is not true, because even though the speed is constant, we know that the direction is changing, which is part of the velocity. The velocity is increasing because the direction is changing. Velocity is not increasing. That would be acceleration. That would not be velocity. And the velocity is decreasing because the speed is constant. Again, those two would both be acceleration, not velocity. Okay, 4. When an object is acted on by an unbalanced force, the object will always do what? Well, unbalanced. Here we have unbalanced. Unbalanced is always going to cause what? A change in motion. We have told you guys that over and over and over. Unbalanced means a change in motion. Which one of these is a change? Well, we know accelerate is definitely a change in motion. It's speeding up, slowing down, or changing direction. Continuing the same. Well, that word same is definitely not change. Continuing at the same speed, we got that word same again. Both of those would be balanced. Balanced. And then come to a stop. No, not always. It's not always going to come to a stop. Sometimes it might start it. Sometimes it might speed it up or turn it down. So here the question was always. What will it always do? They will always accelerate the motion.
Okay, number 5. A student was traveling to see his grandmother. His grandmother lives 15 miles north. Okay, so here we've got a distance. Here we have a direction. So already, I'm already thinking velocity. So I'm just going to put velocity off to the side of his home. He started from rest, so he stopped, and maintained a pace of maintained. So this maintained means that he kept it. He kept a pace of 4 meters per second. So right here is my speed before stopping. So what is he doing right here? He stopped and he maintained this. He went at a speed of 4 meters per second. Now he stopped again. So already now instead of velocity, I'm thinking he's accelerating at his grandmother's house for lunch. Which of the following best describes the speed, the velocity, and the acceleration of the student's walk? So he traveled at a speed of 4 meters per second north. This is not a speed, that is a velocity, so this one is wrong. I'm not even going to go on. He traveled at a speed of 4 meters per second. Meters per second is a speed, so I like that. With the velocity of 4 meters per second. Okay, we're looking for velocity. There's no direction here. So that one's wrong. He traveled at a speed of 4 meters per second. We like that one. With the velocity of 4 meters per second north. There's my direction. I like that. And his acceleration changed when stopping for lunch. Like that. But just want to make sure there's not a better answer. He traveled at a speed of 4 meters per second, velocity of 4 meters per second north, and its acceleration did not change when he stopped. That is not true. He was going and then he slowed down to stop, so this C is the correct answer. 4 balls made of different material were placed on a tabletop 2 meters from the floor. So they're all at the same height. Which ball has the greatest amount of potential energy? Well, we talked about potential energy is the stored energy. And we talked about that it depends on 2 things. It depends on height and our position more so, and mass. Now, I like to think about this as the potential to being injured. So just off the top, it's either going to be the largest or the smallest. So I'm going to go ahead and eliminate those 2. Would you rather me drop a plastic hollow little ball on your head or a solid plastic ball that's about 10 times more? The one with the larger mass is going to have the more potential to hurt you. So it is going to be D, or ball D, which is J. Number 7, the diagram shows changes in a desert rock formation over time. The changes in the rock formation occurred as rock was worn away by wind-blown dust. This is important. What type of energy is most responsible for wearing away the rock? Well, kinetic energy we know is moving energy. Radiant is from the sun. Potential energy is stored energy, and chemical energy is food. So wind is moving. So therefore, the correct answer is going to be kinetic energy.
Okay, number 8. The diagram below shows a race car traveling around a racetrack at a constant speed of 150 kilometers per hour. 150 kilometers per hour. At which point is the car accelerating? Well, in order to accelerate, you have to be changing something. You have to change your speed or your direction. You have to change your velocity. The only time that velocity is changing is when it's turning, because it's changing direction. The problem says that the rest of the time it's going at constant speed, so then the only time that it's accelerating would be point B. Okay, number 9, Carly constructed a ramp by placing a 1 meter long board along a stack of 6 blocks as shown in the diagram. Using ProbeWare, she measured the speed of the car as it rolled down the ramp. Which conclusion best describes what Carly observed? Well, up here at position 1, we see that it is highest up, so that means it has the highest potential, and it is going the slowest, so that it has the lowest kinetic right there. As it goes down the ramp, it speeds up, so its kinetic is increasing, its potential is decreasing as it's getting down lower. So in position 3 down here, it has the lowest potential and the highest kinetic because that is where it's fastest. So letter A, the car has at position 1 has the least amount of potential. That is false. It has the most amount of potential. So that's not the good answer. The card at position 2 has it says the greatest, but that's right in the middle, so nope, that's not the right answer. And card at position 1 has the highest, nope, it has the lowest kinetic energy, it is going the slowest. So D, the card at position 3 has the lowest amount of potential, yes, it's closest to the ground, and the highest speed, yes, we can clearly see that, so D is the correct answer.
No, that'd be
What is the speed of the object represented by the graph? So we should know that speed is distance divided by time. This is a distance versus time graph. So the easiest thing and the one thing that I love to do is look to see where we've got. So we've got 5 right here over 1. My distance is 5 and my time is 1. And because it's a straight line, everywhere on this will be the same thing. So if I continue up here and do this 50 divided by 10 is also 5 meters per second. So that is consistent with the fact that we've got 5 meters per second here. It is a straight line, it's constant speed, and H is my correct answer. Okay, number 11. This is which graph best illustrates the motion of the object based on the data table. So this is a little different. This is basically a time versus speed, not distance graph. So this is a little bit different, but let's look at this. We've got time that goes on as it is. This is going by tenths. So this is basically increasing at a constant rate. So increasing at a constant rate. So at 4 seconds, we know it should be at 40, 5 seconds at 50, 6 seconds, 60, and so on. So the way that this is shown, on a speed versus time graph, so again, this is not distance. So the way this is right here, let's say this speed is right here is 20 meters per second. Well, it's 20, it's still 20, it's still 20. This is showing a constant speed. Okay, remember, this is different than a distance versus time graph. Over here, if we put in some imaginary numbers, which I love to do, 30, 20, 10, what's happening here? The speed is decreasing speed. Over here, again, 10, 20, 30, 10, 20, 30. Over here, this is increasing speed. And here we are increasing speed right in this area, then increasing at a smaller rate, and then increasing speed again. So the correct answer right here is going to be C.
Okay, number 12. The table below shows the results of a student investigation, the speed of a toy car down a ramp. So as it goes down the ramp, we notice the speed is increasing. The speed is increasing. Which of the following statements best explains the data collected by the students shown in the table? The speed of the toy increases. Okay, it does. However, why does it increase? Does it increase due to forces greater than gravity? Well, a force greater than gravity, gravity goes down. A force greater than gravity goes up. Which direction would the car be going if there was a force greater than gravity? It would be going up, not down the ramp. Clearly, it says it's going down the ramp. It's getting closer, further down the ramp. So that is not going to be our answer. The speed of the toy car decreases. Clearly, by the data, the speed is increasing. It goes from 26 centimeters per second to 105. 105 is bigger than 26. So that is not the correct answer. The speed of the toy car increases, yes. Ooh, due to unbalanced forces. Well, we know that unbalanced forces cause what? They cause a change in motion. They cause acceleration. Is that car accelerating? Yes, it is. What causes acceleration all the time is unbalanced forces. The speed of the toy car decreases due to friction. We already established the speed does not decrease, it increases. So the correct answer is H.